Hello everyone. So in this lecture I am going to explain you how to solve the numericals on electrical wiring. So I have considered the one layout. So here I have taken three locations. One is the veranda, room and hall. So total three locations are there. The dimensions are given 6 meter into 6 meter. Okay. So first step is, so we have to assume the total lighting points, total ceiling points and total socket points required for this layout. So in this layout we have to assume how many lighting points are necessary, how many ceiling points are necessary, and similarly how many socket points should be taken as per the Indian standards. So now I have taken the three locations here. V means veranda, R means room, H means hall. So first one I have taken the lighting point. So this is the symbolical representation of light point. So in the veranda, so as per this size of the room, only one lighting point is necessary. So I have considered the only one point, lighting point. Plus in the room, so minimum 2 points should be taken, okay, for this area. So 2 lighting points I have considered. Plus in the hall, again 2 lighting points are necessary. So the total number of lighting points to be required is 5. Okay. Similarly, ceiling points. In the veranda, no ceiling points are necessary. So that's why no ceiling points are considered. It is 0. Plus in the room, again one ceiling point is required. Plus in the hall, also one ceiling point is required. So total ceiling points required is 2. Similarly, socket point. Socket means it's a plug point. 3 pin 5 ampere socket points are used for lighting circuit. So these sockets and may not be necessary in the veranda location. So 0 I have considered, plus 1 for room and 1 for hall. So again 2. So total number of points equal to 5 plus 2 plus 2 is equal to 9. So as per the standard rule, so one sub-circuit should not exceed the total number of points 10 or wattage 800 watts. So now look at here, only the total number of points is equal to 9, so which is less than 10. So only one sub-circuit is necessary for this layout. Or with respect to the wattage, 800 watt should not exceed. So in the next step we will calculate what is the wattage of this total number of points. Next step is, as per the recommendation of Indian standard, the wattage of each point may be considered as 60 watts for the purpose of load estimation. So here I am assuming that the wattage for lighting point, the wattage for ceiling point, the wattage for socket point as 60 watts common for the purpose of load estimation. Practically the wattage for light, fan and socket may be different, but for the purpose of load estimation purpose I have considered only 60 watts common for all the points. So the total number of points is 9. So we can easily calculate the step number 3, that is the total wattage. The total wattage formula is P is equal to number of points into 60 watts per point. So why I have taken 60 watt? Because I have taken common for all the points. Point means that may be light, fan or socket. So total number of points is 9. We got this 9 into 60. This is assumption. So 9 into 60 we got 540 watts. So the total P we got 540 wattage. The next step is calculation of the load current. So the load current I is equal to, we know the formula, P by V. So P is equal to 540. We got the answer, divided by V is the single phase supply for the domestic purpose, that is 230 volt. So if it is not given, you can take 230 only. So I is equal to 540 by 230, you will get the 2.34 ampere. So this is our load current as per the load of 540 wattage supplying 230 volt. So we got the current rating 2.34 ampere. But in future, if you want to add some more electrical points like lighting points, ceiling points or socket points, so future extension purpose, so we need to take the safety factor. Okay, the safety factor means in future if you want to add some more points, so the cable will be using one time during the installation. That's why, so before selection of the cable we need to consider the safety factor for this current rating. So 2.34 into 2 you have to multiply as a safety factor for single phase supply, and 3 you have to multiply for the 3 phase supply. Now it is single phase supply, so I have taken 2. So 2.34 into 2 we got 4.68 ampere. So this is the load current. Okay, the next step is, so we got load current 4.68 ampere, the wattage is 540 watts. So step number 5 is selection of the cable. So in the JB Gupta textbook, it is given in the table 8.3, that is a standard table with respect to the current rating. So which type of cable should be necessary, either it is a copper cable or aluminum conductor cable. So you have to choose the cable by referring this table 8.3 from the JB Gupta textbook. So I am referring the table 8.3 and writing the size of cable required for this layout. It is 2.5 mm square, which can carry the current rating up to 10 ampere. I think this is the minimum cable rating available in the table. This is the minimum cable, 2.5 mm square should be used. So carrying current capacity up to 10 ampere. So our current value is to 4.68. The cable current carrying up to 10 ampere. So it is more than that. So it can be safe for using the cable of this size. Next, we need to find out the total length of PVC pipe. So before going to calculate the PVC pipe, so first we need to assume some basic data. First one, I am assuming that this is the reference point, this line, there is a one number, that is a floor level. Second line indicates the switchboard location. Third line indicates the lighting point location. And fourth line indicates the ceiling point location. This is how the connections are done in the house. So reference floor level, first you can see the switchboard, above that lighting points, above that ceiling points. Okay. So first we need to assume what is the height of switchboard with respect to the floor level. I am taken 1.5 meter. Okay. You can assume this data. What is the height of lighting point with respect to floor level? So reference is floor level. So with respect to floor level, switchboard height is 1.5 meter, and with respect to floor level, lighting point height is 3 meter, and with respect to floor level, the ceiling height is 3.6 meter. So we have assumed the height of switchboard, height of lighting point, and height of ceiling with respect to floor level. So 1.5, 3 and 3.6. So now what we are going to do is, what is the vertical rise point? So reference to lighting point and ceiling, the difference between the light and ceiling, that is called vertical rise. The cable running from lighting to switchboard, that is called vertical drop point. So with reference to the lighting point is also called a HR, horizontal run. So the difference of lighting and ceiling is equal to, this is the total 3.6 meter minus 3 meter. So 3.6 minus 3, you will get 0.6 meter. That is the vertical rise point. Similarly, vertical drop means difference between the lighting and switchboard. So between these, so this is a 3 meter minus 1.5. If you do this, you will get the drop, vertical drop 3 minus 1.5, which is equal to 1.5 meter. So here I written again same thing. Vertical rise is 0.6 meter, vertical drop is 1.5 meter, wall cross I assumed 0.5 meter. Okay. So next important step is step number 7, that is a wiring plan. So just for your understanding purpose, I am writing the steps. Okay. So in the wiring plan, so again I have drawn the blank layout. Okay. So just to mention locate the points, lighting points, ceiling points and socket points in this layout. So first I have taken one lighting point in the veranda, 2 lighting points in the room and 2 lighting points in the hall, and 1 ceiling point in the room and 1 ceiling point in the hall, and 1 socket point in the room and 1 socket point in the hall. So location of all the points that you have to do first. Here I mentioned the few symbolic representation of horizontal run, dotted lines. A straight line indicates the heating circuit. Okay. And this is the M1, M2 indicates a emitter and main board. This symbol is lighting point, this symbol is ceiling point, this is the socket point, and this is the exhaust fan. So coming to the wiring plan, so we know that we have taken the lights 5, ceilings 2, socket points 2, total 9 points we have taken. So total 9 points you have to mention in the wiring plan. So L1, L2, L3, L4, L5 are the 5 lighting points. Okay. Similarly, C1 and C2 are the 2 ceiling points, and SP1, SP2 are the two socket points. Total 9 we have taken. Same we have done the calculations. So now, so very important, all of you listen carefully. So in the location, first you draw the table, location, horizontal run, vertical rise, vertical drop and wall cross. Okay, and this is the total length of pipe. So we are doing the total length of PVC conduit calculation. So location, veranda, room, hall. So all the dotted lines indicating in this layout, that is called horizontal run. So first see horizontal run calculation for this veranda. So here you can see the dotted lines indicating in this room. Only this location you can observe. So from this point to this point, the 2 meter is given. So 2 is I have written here, plus this line, the dot lines from this point to this point. It is half of exactly this dimension, that is 3 meter is given. So 3 by 2 is 1.5 meter. So only half is connected here. So this is the length of pipe required from this point to this point is 1.5 meter, and this line is 2 meter. Similarly, a room, second room, this completely dotted lines indicating 3 meter. So 3 are written, plus the dotted lines of up to L3 point, up to ceiling point and up to L2 point. So that is 1.5, so sorry, 2, 2, 2, because this is given is 4 meter. So half of this is 2 plus 2 plus 2. Similarly, in the hall, this complete length is 6 meter. So 6 is written first. Next, so L5 connection, C2 connection, L4 connection, that is given 1.5, 1.5, 1.5, because this is 3 is given total dimension. So half of this means, so 1.5. So this is how you have to calculate the horizontal run. Vertical rise means only wherever you have the ceiling points, in that location use the vertical rise value. Vertical rise already we have done calculation, 0.6 meter we got. Vertical drop we got 1.5 meter and wall cross we got 0.5 meter assumption. So vertical rise in the veranda, no ceiling points considered, nil, it is 0. In the room, one ceiling point we have taken, and in the hall one ceiling point we have taken. So vertical rise is 0.6 and 0.6. Vertical drop means wherever the switchboards you have taken, there you have to mention the vertical drop point. So in this layout, vertical drop means one meter board is there, one SP1 is there, one SP2 is there. So 1.5 meter, 1.5 meter, 1.5 meter. In all the 3 locations, one switchboard we have taken. And wall cross means wherever the cable running from one location to another location, room number 1 to room number 2, so on. So there you have to consider the one wall cross. So from this veranda to room, the cable has to move. So one wall cross I have taken. And from this room to hall, the cable has to run. Again one wall cross I have taken. So 2 wall cross I have considered, assuming 0.5 meter as a wall width of the wall is 0.5 meter. So 0.5 and 0.5 I have taken as a wall crossing. So the total value you have to calculate. So in the veranda location, so add all the things, you will get 5.5, second 11.6, third 12.6. So we got the answer 29.7 meter. So just round off is 30 meter approximately. Then add the 10% wastage to this value. So 30 meter means approximately 3 meter is the wastage. If you take 10%, then the total length of PVC conduit pipe is 30 plus 3 is equal to 33 meter including wastage. So once you got the total length of pipe, then to calculate the total length of cable, so it is very easy. Just to take this formula, that is a total length of phase wire plus total length of neutral wire is equal to 3 times the length of pipe or conduit. So 3 pipe calculations already we have done, 33 meter, 33 into 3 you will get the 99 meters. This is the total length of 2.5 mm square aluminum conductor cable. So this is the calculation of lighting circuit. Similarly you can do for the heating circuit also. So in this lecture we have understood the how to draw the wiring plan circuit, how to do the current calculation, how to take the size of the cable, and also how to calculate the length of conduit and cable. So in the next lecture I will discuss the heating circuit also. So just to watch this video so 2 to 3 times, so you can understand all the details. So I will share this this notes in the Google Classroom, so refer it. Okay, so in the next class again I will take one more numerical on the wiring circuit. Okay, thank you.